In this video we are going to talk about rare golden scarab beetles. So before starting this video, please like this video and subscribe to this channel for our future updates. Collectors place a high value on the ornate insects, which have a dazzling metallic gold color and are extremely detailed. However, the reasons for its golden iridescent tint have remained a mystery up to this point in history. Color and light specialists at the University of Exeter have conducted studies to determine the origin of the scarab beetle's remarkable metallic golden appearance. The results have revealed that the golden beetles have a distinct optical signature that can only be found in their species. The beetle's structure, as well as its armor, is capable of manipulating the way light is reflected in such a way that it appears to be pure gold. Professor Pete Vukusic, a physicist with a specialization in light and color, was in charge of the research, which included experiments as well as advanced modeling techniques. He discovered that the golden appearance of the beetle's exoskeleton is due to the great reflectiveness of their exoskeleton, which also manipulates a feature of light known as its polarization, which is the orientation of the oscillations of the reflected light wave. Using circularly polarized light to map the optical signature of the beetle's color, the researchers found it to be optically ambidextrous, which means it reflects both left-handed and right-handed circularly polarized light. Professor Vukusic made the following statement: "The scarab beetle Chrysina resplendens is distinguished by its brilliant golden color and distinctive polarized reflection, which distinguishes it from the hundreds of thousands of other beautiful and brightly colored animals and plants found throughout the natural world. Because of its dazzling, golden look, it can reflect both right-handed and left-handed circularly polarized light at the same time on its exoskeleton." In the current state of knowledge, Chrysina resplendens possesses a characteristic that appears to be uncommon and exquisitely specialized in comparison to other animals and plants. A useful platform for the development of bio-inspired optical technologies will be established. The golden jewel beetle is highly sought after by collectors because to its similarity to the valuable metal gold, which makes it an excellent investment. Other scarab beetles, which were prized by ancient civilizations such as the Egyptians for their usage as amulets, and which were sometimes wrapped in the bandages of mummies, are colored in jewel-like green and blue hues. The vast majority of vividly colored beetles are green in color and do not reflect polarized light, despite their appearance. In comparison to Chrysina resplendens, which has a dazzling golden coloration, these beetles' exoskeletons are significantly less specialized, with only a few specialized components of their beautifully complex construction. Dr. Ewan Finlayson, a research fellow on the project, shared his thoughts on it. Besides its spectacular metallic golden look, we were driven to the study of this jewel scarab because of its capacity to modify a less evident aspect of the reflected light, its polarization. The intricacy and detail contained within these optical signatures, as well as the intricate natural systems that generate them, have been demonstrated to us. It is thought that the golden gem scarab beetle Chrysina resplendens, which is primarily found in the Americas, has evolved an exoskeleton that incorporates sophisticated nanostructures that are responsible for the look of the creature. According to the findings, the spacing between repeated layers of the nanostructures varies over a certain range through the exoskeleton, a critical trait that results in the simultaneous reflection of a variety of visible colors. This is the reason for the extremely dazzling reflection, as well as the golden color of the glass. The nanostructured exoskeleton is made up of natural components such as chitin and a number of different proteins, among others. Additionally, these structures are noteworthy in the way they modify the way polarized light is reflected, which is in addition to their spectacular reflectiveness. In order to produce circularly polarized light, their nanostructures must oscillate at a frequency that is different from one another as the light travels through the space. Rotation can occur in two different ways, which are referred to as left-handed and right-handed. A pioneering American scientist named Michelson laid the groundwork for the studies that are being conducted today. It is estimated that there are approximately 100 species of Chrysina jewel scarab, all of which are found only in the New World, primarily in Mexico and Central America. It is only in Panama and Costa Rica that you will find the Chrysina resplendens. Scarabs of the genus Chrysina are generally found in highland woods. The larvae eat rotting logs of several tree species, while the adults eat leaves and other plant material. The larval stage can last anywhere from a few months to a year, and pupation takes about a month and a half. After the adult emerges, it continues to survive for approximately 3 months, however the exact length of time depends on the species in question. Crypsis, or the ability of an animal to blend in with its environment, is one possible explanation for the beetle's highly reflective exoskeleton's extremely reflective look. However, it is not quite apparent why these beetles are such a bright golden color, but one possibility is that it serves as a form of camouflage under certain lighting situations. The beetle's bright golden color may also alter how it is seen by predators as it moves, potentially causing them to become distracted. There are many species of iridescent beetles, but jewel beetles are one of the most charismatic and highly colored, and their color may be exploited in the mating process. It is not known how other beetles perceive the gold color and reflected light, though this is a possibility. Many tiny mammals would be unable to differentiate the golden color from other colors such as reds, greens, and yellows, but a predatory bird would almost certainly be able to discern these colors. What do you think of our video? Let me know in the comments section below. If you enjoyed this video and want to hear from me again, be sure to hit that subscribe button before you go. Thanks for watching.